Hi scientists, I'm Professor Beakerz with Beakerz Science. I hope you had a ton of fun experimenting with your Lunchbox Science Kit. We called it Lunchbox Science because we wanted to show you how simple and close by your science experiments can be, right in your kitchen. We are covering mostly matter. I'm going to go through your experiments to show you how we do them. Maybe you did them the same way. And then I'm going to show you a new experiment. Okay, so we're going to start with the three states of matter: solids, liquids, and gases. They behave differently. So the particles in a solid are very close together and they don't move. Whereas liquids, they are very flexible. They actually can take the shape of any container you put a liquid into. And then gases, they spread far apart. They expand. So we're going to watch the behaviors of the three states. So our raisins are the solid, and by themselves, they don't do anything. So as I put them in the cup, they're going to stay right there in the bottom of the cup. If I add a liquid, which is in this soda can here, depending on the density, it could float in the liquid, but our raisins are more dense than our water. But something else is in this soda water. Can you guess what it is? That's right, it's a gas. It's carbonated. And so the gas expands and moves up. So we're going to pour our soda in here and see if the liquid and the gas has any impact on the solid. All right, here we go. All right, so our solid raisins are on the bottom, but pretty soon you're going to see the bubbles of gas attach to the raisins and carry them to the top. And then as the gas lets go, they drop back down. Pretty cool. Okay, good job, raisins. Now we're going to talk about applying energy to matter. And we are going to be applying thermal energy, or heat. So I heated some water, and we're going to put the hot water in 1 cup. Always make sure you have an adult with you when you experiment. And then I have some ice water. I put some ice in there to cool it down. So we applied energy to the hot water, and we removed energy with the ice. And now we're going to see what heat does to matter. So we heated this water. When you apply heat, it actually causes the molecules to move faster, okay? And we are going to test that theory by dropping food color. So if we're right, then when I drop the food color in, we should be able to see the color mixing in quickly. We'll find out. And if I put it in the cold water where we've removed energy, what happens when it's cold? Well, it slows down. All right, so let's see if that's what's happening here. So we'll put a drop there and a drop there, and we'll see which one mixes faster. Can you see? So what I see is the food color in the cold water sinking, which is what happens. And the food color in the hot water is actually mixing in and rising up. Can you see the string of color there sinking down? Pretty cool. Okay, what did you guys find? I'd love to hear. All right, so let's move on to polymers. So molecules are made up of atoms that are bonded together. Polymers are made up of a long chain of the same molecules. And they aren't solid and they aren't liquid, but they have characteristics of both, okay? So they're definitely flexible. And we are going to test that. We're going to test how flexible it is by pouring water into our polymer bag here. Lovely. And we are going to use this sharpened pencil to poke it. So a polymer should flex around this pencil and seal it. There we go. Didn't come out. Our polymer did its job. Did you guys have the same outcome here? I hope so. You should. Okay, now we're going to move on to energy, so this is your one energy experiment. You have a wood dowel and you have a notebook spiral. And we are going to create what's called stored energy. Now I make sure that the dowel or the spiral is sitting above my fingers so it doesn't get caught. So when we pull the spiral back, we are actually storing energy, okay? It's not doing anything yet, but now it's going to become kinetic when we let it go, okay? So pull it down and there it goes. Were you guys able to do it? Kinetic energy is when it's moving. Okay, now to our new experiment. Back to matter. We are going to see what happens when we have a solid, which this is a denture cleaner, or maybe you have retainers that you clean, or those Invisalign, I don't know, or maybe you have false teeth, I hope not. But these are denture cleaners, you can find them at the store. And this is our container. So when we add water to this denture cleaner, there is a chemical reaction. And that happens when certain types of molecules come together, they react. And when the liquid and the solid touch, they create a gas, okay? And where does gas like to go? That's right, it expands, it goes up. So my question is, what will happen if we trap that gas? Will it build up and try to push the lid off? Will it give up and just take a nap? I don't know. So I have 3, but I'm going to show you the reaction first. So come on in here and you can see the reaction happening. So it's bubbling up there. So the gas that you see is in those bubbles, but there's actually a lot more gas, and now it's going to overflow. So we're going to create that chemical reaction, but we're going to close the lid and trap that gas. So what do you think is going to happen? Go ahead and make your guess, and then we are going to see what happens. This is why I have a mat, because things get a little crazy. Here we go, ready? All right, I'm gonna put my safety goggles on because, you know, you never know. The gas found its way out. The fun thing with these is you can keep closing them to see how long that chemical reaction will happen. Ah, there it goes again, it came out. Gas likes to move, it doesn't like to be trapped. All right guys, I hope to see you soon.